Okay, now we're going to look at higher order derivatives. And so if you have your function, then we have the symbol for the derivative is dy dx. And the prime symbol is f prime of x. When it comes to a second derivative, the second derivative is the derivative of the derivative. And so, symbol-wise, it's f prime of f prime. And so what we do with that is we put two prime symbols. Now when it comes to the d notation, though, it's a little bit tricky of how that works. It is the d dx of dy dx. This symbol here means d over dx means take the derivative with respect to x of whatever's after it. And so we're going to take the derivative with respect to x of dy dx. And so what happens with the symbol there is that it gets written as d squared y over dx squared. It's kind of weird where they put the squares at, but that's what you have to do. And so there we have the symbol for the second derivative. The prime symbol is going to be 2 primes. These 3 questions have us taking the second derivative. The 2 questions, 13 and 14, have us taking the second derivative, and then the third question, question 15, has us taking the third derivative. And so if y is equal to that 7x cubed minus 5x squared plus x, then your derivative, who has the symbol dy dx, or y prime, is copy down the 7, the constant multiple rule, bring down the 3 and take x to the 2, that's the power rule. Copy the minus 5 down, that's both the difference and the constant rule. Now we have x squared, so we bring down the 2 and take x to the 1, or just leave that alone. And then we have the derivative of x, who is 1. That's using the rule that if you have a linear function, the derivative of it is just the slope of the line. All right, great. So simplifying that, we have 21x squared minus 10x plus 1. That's your derivative. Now we're going to take the derivative of that. Okay, and the symbol is going to be d squared y over dx squared. Keep the 21, bring down the 2, and we have an x. And then minus 10, the derivative of mx is m. And so the simplified version of that is 42x minus 10. That is your second derivative of the original function. And with polynomials, then we're going to have that each time you're going down 1 in exponent. So we start with a cubic. Its derivative is a quadratic. The derivative of a quadratic is a linear function. Okay, great. Now this next question, 14, we need to do some algebra to it first to start out with. Because if we leave it as it is, we'd have to do a rule that's taught later. We have to do the quotient rule. But now, we can fix this as take advantage of the rule that if you have multiple terms in the numerator and a single term in the denominator, this is one fraction, but what you can do is split it into 2 fractions. Undo the simplifying and divide each one of them by that constant in the denominator, or whatever is in the denominator. It doesn't have to be a constant. And so 1 minus x all over x is the same thing as 1 over x minus x over x. And that simplifies to be 1 over x minus 1. So that's what your function is going to be. We're going to use that. Actually, one more algebra step. We're going to call that x to the negative 1 minus 1. That's your function. And so with that function, y equals x to the negative 1 minus 1, we can take the first derivative, and get negative 1x to the negative 2. As far as minus 1 derivative, remember that's 0. It's constant. Any constant function has 0 as its derivative. Then we go take a second derivative. We keep the minus 1, we bring down the minus 2, and we take x to the minus 3. Just each time you're taking away 1 from the exponent. Simplified version of that is going to be 2x to the negative 3. Okay. All right, great. Well, if the second derivative is the derivative of the first derivative, then the third derivative is the derivative of the second derivative. Now, the symbol gets a little strange if you do the d notation. It's d dx on d squared x. I'm sorry, d squared y dx squared. So if you're going to use the d symbol, it's going to be trouble, but it's what it is, though. It is d cubed y over dx cubed. Or you can just go with the prime symbol, triple prime on y, or triple prime on f, however the function comes at you. And so our function comes out as x to the negative 5 plus x to the 5. First derivative, power rule. So we're going to have the negative 5 come down, take x to the negative 6. Remember, you're taking away 1 each time from the exponent. Plus sign, because it's the sum rule. Bring down the 5, take x to the 4. And there's your first derivative. Then we have a second derivative. We already have the negative 5 there, and then down comes the negative 6. And then x goes to the negative 7. We already have the 5 there, then down comes a 4, and then x goes to the 3. The simplified version of that is 30x to the negative 7 plus 20x to the 3. And now we're on to the third derivative. Keep the 30, bring down the negative 7, and take x to the negative 8. Keep the 20, bring down the 3, and take x to the 2. All right, great. So, simplifying that, we'll have our final answer as the triple prime. The third derivative is negative 210 x to the negative 8 plus 60 x to the 2. Okay. All right, great.